Stop right now. Freeze this moment. What do you feel? This is now, right? A real, tangible present. But here's the problem. While you were reading that sentence, now already became then, and the new now is already slipping through your fingers. And here's what's truly terrifying: physics claims that what you just experienced doesn't exist at all. Albert Einstein proved this in 1905. Imagine two astronauts flying in opposite directions at near the speed of light. On Earth, a supernova explodes. The first astronaut sees the explosion at the same time you sneeze. The second sees it at the same time you have breakfast 3 hours later. Who's right? Both of them. For the universe, there is no single now. It's a local illusion of the observer. Your now is not my now. But wait, you say. I clearly feel the difference between the past and the future. I remember breakfast, but I don't know what will happen tomorrow. This isn't an illusion. It's reality. My memory isn't lying. This is where the mystery begins. What if I told you that the fundamental laws of physics don't distinguish between the past and the future? Newton's, Maxwell's, Schrödinger's equations, they all work the same in both directions. Film billiard balls and play it backward. Physics wouldn't know the difference. In mathematics, time is just a variable that can be replaced with negative time, and nothing changes. So where does the arrow of time come from? Why does an egg break but not reassemble itself? Why do we age only one direction? Why does the universe remember the past but not know the future? And the most terrifying part, what if the answer is that time doesn't exist at all? Let's test this claim. Take the simplest example, Newton's law. Force equals mass times acceleration. Now, imagine you throw a stone into water. It flies in a parabola, enters the water, and creates ripples. Record this on video. Now, play it backward. The stone leaps out of the water, the ripples converge toward the center, and the trajectory is perfectly mirrored in reverse. Newton's equations describe both processes identically. Replace time with negative time. The math sees no difference. For physics, both directions are equally valid. Okay, you say, but that's mechanics. What about electromagnetism? Maxwell's equations, which describe light, radio waves, and magnetic fields. In 1864, James Maxwell wrote down 4 elegant formulas. And you know what? They are also time-symmetric. An electromagnetic wave propagates the same way forward and backward in time. An antenna can radiate a signal or absorb one from the future. Mathematically, it's the same thing. Quantum mechanics, the Schrödinger equation, the foundation of all modern physics, from 1926. It describes how a particle's wave function evolves, and guess what? It's reversible. A quantum particle can remember its past state with perfect accuracy if you run time backward. No information is lost. Einstein's general theory of relativity, from 1915. The equations of gravity, the curvature of space-time around massive objects, black holes, the expansion of the universe, gravitational waves. And yes, these equations also don't distinguish between past and future. A gravitational wave can travel from a source or toward it. See the pattern? All the fundamental laws of nature, from a falling apple to a collapsing star, are symmetric in time. In the language of mathematics, the past and future are indistinguishable. Physics has no arrow of time. But wait, there is one exception. The only law that distinguishes between directions. The second law of thermodynamics: entropy always increases, disorder always increases. A broken cup doesn't reassemble itself. Stirred coffee doesn't separate back into milk and espresso. Heat flows from hot to cold, not the other way around. There it is, the arrow of time. Physics has finally found an asymmetry. Ludwig Boltzmann formulated this mathematically in 1810. Entropy is a measure of disorder, and it can only increase. But here's the catch. Boltzmann proved this isn't a fundamental law. It's statistics. At the level of individual atoms, the reverse process is possible. All the molecules of a broken cup could randomly reassemble. It's just that the probability is so astronomically small you'd have to wait longer than the age of the universe. The arrow of time isn't a law of nature, it's a bet on incredible odds. And this leads to a paradox that tormented Boltzmann himself. If entropy has always been increasing forever, from an infinite past, why hasn't the universe already reached maximum chaos? Why aren't we in a state of heat death, where all particles are uniformly distributed and the temperature is the same everywhere? Why does order, stars, planets, even exist? There are 2 possible answers. Either time had a beginning, a moment of incredibly low entropy we call the Big Bang, or we are a random fluctuation of order in an infinite sea of chaos, a statistical anomaly that will soon disappear. Boltzmann chose the first option, but he couldn't prove it. And in 1906 he took his own life. So what does this all mean? Fundamental physics has no arrow of time. The only asymmetry is a statistical accident. But then why are you so certain you remember the past and not the future? Maybe the issue isn't with physics. Maybe the arrow of time is in your head. Stop right now. Freeze this moment. What do you feel? This is now, right? Now, a question: when exactly did this now begin? When you started reading the sentence, or when you finished? Or somewhere in between? Here's the problem. While you were looking for the answer, now already became then. And the new now is slipping away faster than you can grasp it. In 1983, neurophysiologist Benjamin Libet conducted an experiment that shattered our intuition about free will. He asked people to perform a simple action, flexing a finger, and to note the moment they decided to do it. The result? The brain began preparing the movement 350 milliseconds before the person was consciously aware of the decision. Read that again. Your brain initiates an action, then a third of a second later you become aware of it. And you think you made the decision now. Your now is a retrospective construction. You don't live in the present. You receive a report about the past and call it the present, but that's just the beginning. In 2009, neuroscientist David Eagleman showed that the brain works like a bad translator at an international conference. Vision sends a signal in about 80 milliseconds, hearing in 50, touch in 30. All these streams arrive at different times, so what does the brain do? It waits. It gathers the scattered pieces of reality. It edits them into a single package, and only then does it present it to you as a moment. What you call now is already the past. A delayed broadcast with an 80 millisecond lag. You are living in the past, packaged as an illusion of simultaneity. But wait, you say, 80 milliseconds is nothing. Doesn't mean time doesn't exist, just means the brain is slow. All right. Then here's a tougher question. In 1997, psychologist Ernst Poppel measured the duration of the psychological now. It turned out to be about 3 seconds. Everything that falls within this window you perceive as simultaneous, a musical phrase, the sentence you are reading right now, a gesture from someone you're talking to. This isn't a series of separate instants. For you, it's a single moment. But physically, these events are spread out in time. The notes in a melody don't sound at the same time. The words in a sentence are spoken sequentially. Your brain glues them together into an illusion of unity. It creates a now where physically there is none. And here's what's truly frightening. If the brain manufactures the present from the past, what is real at all? Could the flow of time just be the way consciousness packages information? Perhaps in the physical universe, time really doesn't exist. There are only us, observers, doomed to live in the illusion of now. But this raises an even scarier question. If the present doesn't exist, what are the past and the future? Imagine a reel of film. All the frames exist simultaneously, the first, the 100th, the last. They don't appear one by one. They simply lie on the film motionless, eternal. You watch the movie and see motion. But that's an illusion. The projector moves a beam of light from frame to frame. The frames themselves don't move. They don't even know the others exist. In 1949, physicist Hermann Weyl proposed that the universe is structured the same way. All moments in time exist simultaneously. The past hasn't vanished. The future already exists. You're simply shifting your focus of attention, like a projector on a film reel. This is called the block universe. And here's what it means. Your birth exists right now, not in your memory, ontologically, as a real event in four-dimensional space-time. Your grandmother's death didn't disappear into the past. It exists in its own block just as really as you reading this text. Moreover, your death already exists, somewhere in a future part of the block. You just haven't reached that frame yet. Sounds insane? But this idea has ironclad proof, Einstein's theory of relativity. Remember the problem of simultaneity? Two observers moving at different speeds cannot agree on which event happened now. For one, the star's explosion happened before your breakfast. For the other, after. If an objective now doesn't exist, then all moments are ontologically equal. There is no privilege present. There is only a block of events from which each observer carves their own slice. Philosopher J.M.E. McTaggart reached this conclusion back in 1908, 7 years before Einstein. He proved that if time were real, an event would have to be simultaneously future, present, and past. But this is a logical contradiction. Therefore, either time doesn't exist at all, or it is an illusion. And now for the most unsettling part. In the equations of loop quantum gravity, physicist Carlo Rovelli's work contains no time variable at all. At the fundamental level, the universe is a timeless network of events. Time only emerges in the macro world, like temperature, like pressure, an averaged property of many particles. You're not moving through time. You are a pattern in the block, experiencing itself sequentially. But if all moments exist simultaneously, where does the difference between past and future come from? Why do we remember one but not the other? Here it is, the final asymmetry that physics cannot explain. You remember breakfast, you don't remember dinner, say? The standard answer, because breakfast has already happened and dinner has not. But we've just established that in the block universe, both events exist with equal reality. Your breakfast at 8 a.m. and your dinner at 7 p.m. are two equally valid blocks of space-time. So why does memory only work in one direction? Physicist Wojciech Zurek found an answer in 2003, quantum decoherence. When a quantum system interacts with its environment, it leaves a trace, entangled states. Information is recorded into the structure of the universe like a scratch on a vinyl record. The past leaves traces, photographs, fossils, neural connections in your brain. The future leaves no traces, because those interactions haven't happened yet, or more accurately, because you are on the side of the entropy gradient where the records already exist. There it is, the arrow of time. Not in the laws of physics, in thermodynamics. Cosmologist Sean Carroll explains, the universe began in a state of incredibly low entropy. The Big Bang wasn't just the beginning of space and time, it was the beginning of order. Since then, entropy has been increasing, information is smearing out, cups are breaking, memory is an entropic process. To record a memory, the brain must increase entropy somewhere else. Burn glucose, release heat, dissipate energy. You remember the past not because it's more real than the future, but because you're in a thermodynamic flow from order to chaos. But this is where things get really strange. In 1978, physicist John Archibald Wheeler conducted a delayed choice experiment. A quantum particle passes through two slits. You decide to measure its path after it's already passed, and your decision in the present determines what happened in the past. The past is not fixed until it is observed. Perhaps consciousness doesn't just perceive the past, it creates it. By choosing from a superposition the version of history that aligns with the present, neuroscientist Carl Friston has shown that the brain doesn't reflect reality. It predicts the future half a second ahead. What you see now is a model of what is expected to happen. You live in a simulation of the future, thinking it's the present, and you remember a past that may have been created retroactively. So where are you really? Stop. Right now. Freeze this moment. You just learned that time may not exist. The present is an illusion. The past is created after the fact. The future already exists somewhere in the block universe. Now what? You still get older, your cells decay, the people you love die, the world changes, irreversibly, cruelly, definitively. Physics says time is symmetric, but your life is not. In 1889, philosopher Henri Bergson distinguished between two kinds of time. Clock time, measurable, quantitative, what science studies, and duration, a living, qualitative experience, the one you exist in. Science studies the first, but you live in the second, and perhaps both truths are real, just on different levels of description. Here's what I've come to understand after this journey. If the block universe is real, then every moment of your life exists forever. Not will exist in memory, it exists ontologically, right now and always. This moment, as you read this sentence, it won't disappear. It is woven into the fabric of space-time forever. Your first kiss, the death of someone you loved, the morning you woke up happy for no reason. All of it exists simultaneously, in the eternal now of the universe. This can be terrifying. Determinism, lack of freedom, the inability to change the past, or it can be comforting. Nothing is ever lost. Every moment of joy is eternally real. The choice of interpretation is yours. But here's what truly fascinates me. Why is the universe structured in such a way that beings like us inevitably ask this question? Why did evolution create a consciousness that lives in the illusion of now? Wasting energy on constructing a non-existent present? Maybe the answer isn't in physics. Maybe that the illusion is the only way for an observer to exist. Without a now, there would be no choice, no action, no you reading this. The block universe may contain all moments at once, but to live them, you need someone moving along that film reel, frame by frame, creating the illusion of flow. Perhaps consciousness is time, the only place where it truly exists, and that is the only fact I'm sure of. Right now,